Hello, this is ESPIN Adam. We're happy to assist you with the upcoming presentation. Let us know if you need any help, and we'll be glad to be of service. Industrial Control System, Architecture, Protocols, and Security. Industrial Control System or ICS play a pivotal role in various industries by enabling the automation and control of industrial processes. Here are key takeaways from this topics. Introduction to Industrial Control System. Definition is referred to a collection of hardware and software systems that control, monitor, and automate industrial processes. It commonly found in industries like manufacturing, energy production, water treatment, transportation, and chemical processing. At the core, ICS involves systems that use sensors, controllers, and actuators to regulate the operation of equipment and machinery. Key components of Industrial Control System. 1. Supervisory control and data acquisition. Collect data from various sensors and provide a centralized platform for monitoring and controlling industrial processes. Commonly used in industries where real-time data collection and monitoring are critical. 2. Programmable logic controllers, designed to control machinery and processes in real time. These devices receive input from sensors, process the data, and send commands to actuators. 3. Distributed control systems, designed for controlling processes distributed over a large area, such as oil refineries or chemical plants. 4. Human-machine interface, provide a graphical interface for operators to interact with the ICS, which industrial control system. It allows operators to monitor system performance, adjust settings, and intervene when necessary. 5. Remote terminal units, microprocessor-based devices that interface with sensors and actuators in remote locations. They transmit data to central control systems and execute commands from SCADA systems. 6. Sensors and actuators. In ways, sensors are used to monitor physical conditions such as temperature, pressure, and flow rate, while actuators respond to control signals by adjusting valves, motors, or other mechanical devices. Together, they form the backbone of ICS, translating digital instructions into physical actions. Types of Industrial Control System. 1. Supervisory control and data acquisition, designed for real-time monitoring and control of geographically dispersed assets, often over large areas, making them essential in industries such as power generation, water treatment, oil and gas, and telecommunications. Its application is particularly useful in industries where centralized control of widespread infrastructure is critical. 2. Distributed control system, used for controlling continuous and complex processes within a single location, such as oil refineries, chemical plants, and large-scale manufacturing facilities. Its application is ideal for industries with continuous production processes, such as oil and gas refining. 3. Programmable logic controller, specialized industrial computers used for controlling discrete processes, such as those in manufacturing, assembly lines, and machine automation. Its application is widely used in manufacturing, material handling, robotic systems, and other industries that require real-time control of machinery. Industrial Control System Architecture and Functionality. 1. Field layer, comprises sensors, actuators, and field devices that interact directly with physical processes. These devices collect data and execute commands. 2. Control layer, receive data from the field layer and make real-time decisions to adjust parameters. This layer ensures the automation of industrial processes. 3. Supervisory layer, allow operators to monitor and control the process from a central location. The data collected by the control layer is presented to operators in an easily understandable format. 4. Enterprise layer, connects ICS with business-level systems, such as enterprise resource planning and management information systems. This integration helps optimize production schedules, supply chain management, and resource allocation. Industrial Control System Communication Protocols. 1. Modbus, Serial Communication Protocol developed in the late 1970s. Modbus is widely used in industrial automation due to its simplicity and reliability. 2. Distributed Network Protocol, primarily used in supervisory control and data acquisition systems, for communication between remote terminal units, intelligent, electronic devices, and control centers. Popular in sectors like power, generation, water management, and other utilities, where it helps manage remote equipment over long distances. 3. Profibus, Process Field Bus is a field bus communication protocol commonly used in industrial automation environments. Developed in the late 1980s, it is widely used for connecting controllers, sensors, and actuators in automation systems. It recognized for its real-time performance, making it suitable for time-critical industrial applications such as manufacturing, process control, and material handling. Security challenges in industrial control system. 1. Cyberattacks, often targeted by cybercriminals aiming to disrupt critical infrastructure. It can result in physical damage, system malfunctions, and safety hazards. 2. Legacy systems, many ICS installations still rely on legacy systems that were not designed with modern cybersecurity in mind. These systems often lack encryption, authentication, and other security measures, making them vulnerable to attacks. 3. Insider threats, whether intentional or accidental, pose significant risks to ICS. Unauthorized access to control systems, incorrect configurations, or deliberate sabotage can lead to system disruptions or data breaches. 4. Remote access vulnerabilities, necessary for maintenance and monitoring but also creates potential entry points for cyber attacks. Poorly secured remote connections can be exploited by attackers to gain control of critical systems. 5. Unpatched software, keeping ICS software up to date is challenging due to the need for continuous operation. As a result, many ICS installations run outdated software with known vulnerabilities, which increases the risk of exploitation. Strategies for secure industrial control system. 1. Network segmentation. Segregating ICS networks from corporate IT networks can limit the spread of malware and reduce the risk of external attacks. It involves creating isolated zones within the ICS to minimize potential attack surfaces. 2. Access control. Prevent unauthorized users from accessing critical ICS components. Ensuring that only authorized personnel have access to sensitive systems is crucial for reducing insider threats. 3. Regular patch management, essential to address vulnerabilities in ICS components. While downtime is a concern, organizations should prioritize updates to ensure their systems remain secure. 4. Intrusion detection and prevention systems, monitor network traffic for suspicious activity and alert operators to potential security breaches. These systems help detect and respond to threats in real time, reducing the risk of cyber attacks on ICS. 5. Incident response planning, critical for minimizing the impact of security incidents. This plan should outline the steps to be taken in the event of a cyber attack or system failure, ensuring a coordinated response to restore operations quickly. Thank you for watching our presentation. We hope it was valuable and informative. For questions, contact us at info@espincorp.com or visit our website. Thank you again and have a great day.